I welcome all of you the Data Science Workshop series. This series will comprise on 8 lectures. This is lecture number 1 regarding the data collection and data cleaning. We will interact with you every month with a new interesting topic in data science. In this era, the ability to understand and leverage the data is crucial. Data science combines statistics, computer science, and domain expertise to extract the valuable insights from the data, helping businesses make informed decisions, optimize operations, and drive innovations. This free online workshop series is designed to guide you through the fundamental concepts and the techniques of the data science, equipping you with the skills to harness the power of data. Data science using R is essential due to its robust statistical analysis capabilities, advanced data visualization tools like ggplot2, and extensive package ecosystem. Designs for the statistical computing R excels performing statistical tests and predictive modeling techniques. It supports reproducible research with R Markdown and Shiny apps for the dynamic reporting and interactive applications. R integration with the other programming languages, its open source nature, and strong community support ensure continuous improvement and accessibility. Widely adopting R in academia remains a leading tool for the machine learning, AI, big data handling, making it crucial for extracting and communicating valuable insight from the data. What is data? That is the very fundamental questions in data science. Data can be classified as qualitative and the quantitative data. Every research will begins with the identification of the research problem, which initiate with the help of data collection. The very first step after determining the research problem, we have to gather the data. There are the two important types of the data. One is called the qualitative data and other is referred to as quantitative data. Qualitative data can also be categorized into the nominal nature and ordinal nature. These are the two different types of categorical data. And continuous data can be bifurcated into the two segments. One segment is referred to as discrete data and other is called continuous data. For example, in a research problem, if someone is collecting the data like age, so the age of customer is a numeric data and which probably in the form of continuous in nature. Suppose someone is collecting the data about the number of items sold whenever a salesman went to the market for sales. So this type of variable is a discrete in nature. How many items sold by the salesman is a discrete data. On the other hand, there are some categorical data in the problem, like the customer sold an item either to a male person or a female person. So the gender of the purchaser is a data which is categorical in nature, and this type of category is referred to as nominal data. So the things are what? The things are what the categorical data is, what the other data is. We can Now the gender. Gender is a qualitative data. Gender. It has two categories. One is male, other is female. These two categories are referred to as nominal data. This is not normal data. This is nominal data. So nominal data is what? Nominal data is a type in which we have some categories, and the categories cannot be recognized as which one is larger and which one is smaller. On the other hand, if we have customers, the customer number one and the rating of the customer we are interested in, customer number one having the high rating and customer number two having low rating. So rating is a variable in which the two categories we have, low and high. And all of you are familiar that the high is superior than the low. The customer which have a higher score is assumed to be a better customer as compared to the customer who has a low value of the index. So in the same way, we at the time of the collection of data, we should have to be identify what type of data is that and what variable we are going to collect. So this is one of the very fundamental step in starting any research and collecting the data. Instead of the different types of data, there are the two forms of the data. One is called unstructured data and other is referred to as structured data. In social media, most of the data we found in the form of structured data, like all of the data which have multimedia nature is referred to as structured data. For example, customer reviews in the video form. No, this is in the form of the unstructured. Customer review in the form of video, customer review in the form of audio, the customer review in the form of picture or text. All of these reviews are referred to as unstructured data. While in the structured data, we have the data in the form of a table, like customer account number, customer age, and the address, and so on. This type of data, this is customer number one, customer number two, and so on. This is customer number n. And we have a very structured form of this data. The bank customer or grocery store customer or any other customer we have here. So the customer's data in this organized form is referred to as structured data, and the data in the unstructured form, social media data, most of the time having unstructured form. This type of data is called multimedia data. So we have multimedia data, and the multimedia data can be in either audio, video, picture, or text form. Before going to analyze any of the unstructured data, we must have to convert it into the structured form. So this is the one of the very first step in data science. If we have collected the data which is in the multimedia nature, then we must have to convert the data into the structured form, and then any of the model can be applied. Today we have to structure data. We have to clean the structured data. This is our objective. The data is collected and the data is in the form of a structure, in the form of a table, and there are some bugs or some of the errors in my data sets. We have to clean the data set by using some of the techniques. So our discussion will be about the data cleaning in the today's lecture. Collection of data, there are the several techniques, but the two most important techniques which are generally used in statistical analysis are referred to as observational study and experimental design. These are the two major part of data collection techniques. In observational studies, most of the time, the data is readily available. By the surveys, we have to collect that data. Surveys. But in experimental design, it is a controlled experiment. This is a very expensive technique. In most of the scientific research, we have to collect the data by using the experimental design. And in most of the time, the social science data can be collected with the help of the observational studies. I am giving you a very simple example of collecting. Suppose we have the two variable in which we are interested in a research problem. This is the problem. The problem is we have to observe the association between smoking habit and lung capacity. Lung capacity. These are the two attributes in which we are interested in research. In observational study, the data can be collected in a simple way. We have the participants. We have to collect the data from 50 participants who never smoked, and then we have to collect 50 more participants. They were smoking since long. The two types of samples we have. Sample number 1 for non-smokers and sample number 2 for smokers. Sample number 1, 50 participants are selected randomly. Then the lung test were performed for these 50 participants. On the other hand, randomly 50 participants has been selected and who were smoking since long. Then data of lungs will be collected from them. Now we have the two sets of information, the lung capacity data for non-smokers and the lung capacity data for the smokers. This type of data can be readily available, and we call this type of technique as observational study. On the other hand, in experimental design, we have to randomly select a random sample of 100 participants. These 100 participants are those who never smoked. Then randomly we have to organize the two sets. Number 1, 50 elements, 50 participants are to be randomly chosen in a group which are referred to as non-smoker group. Non-smoker group and the smoker group. Again, the remaining 50 participants are to be included in the other group, which is referred to as a smoker group. In the smoker group, we have to wait for 6 months. For another 6 months, these participants are given the smokings for 1 packet of cigarette per day, say till 6 months. And after 6 months, we will have to conduct the lung capacity test for these 50 participants, as well as the lung capacity test for these 50 participants who never smoke during the research project as well as before in life. After completing the 6 months, we have the two data sets. So this is the data collection technique which is referred to as experimental design. So experimental design is a highly equipped experiment in which the data is collected in a very strong, organized way. We have a thorough control over the participants. What type of food we are providing to them, what type of environment in which we are keeping these 100 participants. There is only one difference, and that difference is called, these are the non-smoker participants and these are the smoker participants. So this is the way of organizing the data for observational study and experimental design. So obviously the observational study is quite easy. We have to conduct the survey, we have to make the questionnaire, and then questionnaire can be floated to the participant. The participant will fill the questionnaire and the data is gathered. There are the several tools online available for making these questionnaires, online questionnaires. Google Form is one of the very popular tool which participants can use for gathering the data. Another form is the Microsoft form. SurveyMonkey is a paid service. These two are open sources because Google is free and as well as Microsoft is free. Survey Planet, MailChimp, these are the other these are not open source, these are the paid services. So you have to select any of the tool for making the questionnaire. Then the link of the questionnaire is to be shared with the participants, and the data is collected randomly. I am showing you the very simple part of data collected for this online workshop. All of you were shared a link in which you fill your information, you fill your data. So I am presenting you what type of data is that and how I have collected your data for this workshop series. This is the Google form which I have created. The banner, I have designed the banner especially for this workshop. And then questions are to be framed, title of the participants, the name of the participants. These are the questions. And the different question types we have. If you click over the plus sign, then a new question will be appeared below or at any specific place where it is selected. After framing these questions, the responses you can see 284 participants have registered for this workshop, and responses can be seen in the form of a graph. This graph is representing what type of participants these are. For example, there is a field which named as title. How many are Mr. 157? How many are Miss? 89. How many are Mrs. 10? And how many are doctors? Because in this workshop, too many, 28, around 28 doctors were participating. Similarly, we have another graph and it is the question about what your profession is. Are you a student? Are you a professional? Are you a faculty member? So in this workshop, 38 faculty member has been registered for participation, and the data can be collected in the form of the Excel sheet. If you click at this view in the sheet, so this is actually the worksheet. And you can save this worksheet, you can download this worksheet and save the worksheet in the form of a CSV format. If you save the worksheet in a CSV format, you can download the worksheet into R for further analysis. So this is the way of collecting the data by using a Google form.
The second segment of this workshop is about the data cleaning. For this rest of this part of the presentation, I will use the Toyotocorrola.csv, which contains the several issues. One of the issue is some of the rows are replicated, some of the cells having the missing numbers, and there are some outliers. So I will demonstrate here how to clean the data for further analysis. Before going to introduce the data cleaning perspective, I will introduce the GUI, graphical user interface of R, what the R is and how you have to install the R, what are the two segments of R. One of the basic part of R software is the base R. It is the kernel part of the R, and people have to download this part automatically downloaded, and The second part of the file and the software is the external libraries. For example, if you are going to use some of the visualization using one of the very important library available in @CRAN, named as ggplot2. So if you are using ggplot2, then you have to download the library of the ggplot2. There are the several libraries available. These are the base libraries, which available by default in the base R. And some of the libraries are external libraries. Around 4,000 packages are there on the CRAN, which we can use for the purpose of external packages, and several part of the files can be downloaded. The ggplot2 is one of the famous library for visualization. We will use this library in the second part of the workshop that we will have in the month of July. There are the basic functionalities of R. R is case sensitive. If we have a variable age and we have the variable age, all these two variables are assumed to be the different variable. These are not the two same variable. The case sensitive means you have to use the exactly same case as we used first time at the time of defining the variable. The functions are also be case sensitive. For example, if we are using the function call sum, the exact format is S is capital. Call sum and then square round bracket and the variable name for which you want to find out the column sums. So sum of the all columns will be computed by using this function. R is open source, means there is no licensing fees is involved, and you can download the R from the website freely. The second part is it is available in both of the Mac and Windows. The Mac users can also download the R from the specific source, and Windows is available from the CRAN website. After downloading the R, you have to download the another part of the software, which is referred to as R Studio. What is the difference between the R and the R Studio? R Studio is a GUI and is a front layer on R. R is a compiler. Actual programming is to be done in R, but the facilitation and typing of source file and running and executing the source file, displaying the outputs, this can be done by the R Studio in a comfortable manner. User can use easily R with the help of the R Studio. R manuals are available and R can also be used. This is the GUI of R. There are the 4 major windows in this graphical user interface. And the first layer is on the left-hand corner is referred to as R script. So what is the R script? R script is a window in which you have to code, in which you have to write down all of the commands, and the batch of the commands can be executed by pressing this button, run button. The execution of every command can be done with the help of R, or you have to select 2 or 3 commands to execute them immediately. The purpose of R script is to save all of the commands in a separate file. Whenever you execute a command, the command is placed in the lower part, and the executed output, either if the output is graphical, the output will be shown here. If the output is in tabular or a number format, the output will be shown on the lower left corner of the screen. The second part of the screen is the upper right corner. This is called environment. It has also the few other tabs like history. All of the commands I am using here in this part of the console then will be stored in the history. And similarly, the tutorials, the connections can be seen here. So it has the 4 tabs. You immediately right now you are using environment tab. What environment tab is indicating? All of the variables, all of the data frame that you have created in R are mentioned here. Suppose car LM. Car LM is a model in which we have a list of 12 elements. This is a car data frame. It has 50 observations and the 2 variables. So your RAM is actually reflecting by the environment. Console is actually the R is console. So if someone is asking what's the console is, so I can say that in a simple way, actually the R is console. You have to type the command here. Suppose you have to type 2 plus 3 and press enter, immediately the answer will be shown here. And there is a arrow. This arrow is called in R as prompt. The prompt, every command is started with a prompt, and type the command here and then press the enter button. The command will be executed immediately. So what is the difference between the writing the command in script and the writing command in console? If you are writing the command in script, the commands are recorded, not executed directly. But if you press the enter after the command is executed immediately. The commands are stored here in script, can be run at the user choice whenever user want. The last window is a window in which we have graphs. Plots are there. Every output of the graph will be mentioned here, right? Other tabs of this segment is files, packages, help is one of the very important feature of our console. And the very important feature of our studio is immediately you can check the help of every command, the viewer, the presentation. So these are the most important favorite 4 windows which are indicated by the GUI of our studio. You must be familiar with all of these 4 windows before going to work in R. How the packages are to be installed? The command is install.packages, and the name of the package you have to mention in double quote. Suppose you want to install the package ggplot2, so you have to write down here ggplot2 in double quotes. Your internet connection should be ready and available. This package will be downloaded from the web server and then downloaded into your machine. And this package can be executed by another command, and that command is called require command. So similarly, you have to use ggplot2 here. ggplot2 without double quote. ggplot2, the library. So what is the difference between the install the package and require the package? These 2 commands are necessary to initiate any package. So install command will download the package, and the require command will initiate the package. Once the package downloaded, it will not work unless you initiate the package by the require command or by library command. These 2 commands are the similar command. Any of one of them you can use. Either library you can use, or you can use the require command. After implementing these 2 commands, you can run any of the function into the specific library. Now, the data file which we are using in this remaining part of the workshop, that is called Toyotocorrola2. This file contains the several variables, and what these variables are: the variable ID of the car, the model of the car, the price of the car, and the age of the car. Similarly, the horsepower, how much power the car has. The fuel type is a character variable, diesel, petrol, CNG, gasoline. These are the different types of fuels, but it is stored as a string. So what the strings are, if something is stored in double quotes, we call it in R as a string. This is also a string, and this is also a string. String variables are referred to as CHR, characters. And some of the variables are integers. These are the numeric variables. Some of the variables are the dichotomous variables. What the dichotomous variables are? These variables are referred to as indicator variable. Indicator variable means is a just no variable. ABS. Car have a ABS braking system. 1 means yes, 0 mean no. If is it a sport model? 0 mean no, 1 means yes. It is a sports car. It is not a sport car. So now all of these variables are the indicator variable, yes, no variable, right? For example, parking assistant. 0 means there is no parking assistant, and if there is 1 somewhere, it means it has a parking assistant. So this is the way of defining the variable into, and before going to implement any of the research project, the student and the researcher must have to grasp the knowledge about the each and individual variable into your data file. If you are not understanding your data, if you are not understanding your data file, you cannot work for modeling. The predictions, the forecasting, you cannot done in a good way if you are not understanding the data. Some of the variables are referred to as a very important variable, like the dealer of the car is interested in that, and as well as the seller of the car and the purchaser of the car are also interested in that. Which of the very important variable in which all of the 3 participants are interested to optimize, and that is the price of car. Showroom owner want to sell the car in a good price. The purchaser want to purchase the car in a reasonable low price, and seller of the car is interested to get the maximum price of his car. So that is the most important variable into my data file. I will refer to that as a dependent variable. So most of the time, the research question is about your dependent variable. So you must have to identify your dependent and the independent variable into your data file. So your DV is price of car. P is capital. You should know the case sensitivity of the R. P is capital. So every time whenever you are using the price variable, it is capital P. And the rest of the variables are IV. IV means independent variable. If your car having low kilometer means it is a new car, and very less kilometer it ran. So means you will get the good price. It means the price and the kilometer have a strong association. If your car having an age which is very low, means a new car, so you will get a better price. If your car is very old, so it means the price and age have association. The price and the kilometer also have association. So we must have to identify on what important factors the price of the car is closely associated to build a model. So this is a very important feature of data science, and data scientist has to work on it and identify appropriately the dependent and the important independent variables. Now, the first thing is to read the file into your R. The command is read.csv command. CSV stands for comma separated values. This is a very important and the universally used format of your data tables. And the name of the file is Toyotocorrola2.csv. This file is already provided to you. You have to use. If your file is not stored into the current folder, so you must have to specify the path here. What the path is a list of folder in which your data file is stored. So if your data file is not in the current folder, so you must have to specify the path of the file. After creating this data frame, this is the local name of the file. This is the physical name of the file. So in R, I will use one time after reading the file, the rest of the presentation, I will use a CARDF. DF stands for the data frame. The tables in database are called data frame in R. So we have the tables and tables are called data frame. You can see the structure structure of the car data frame. The structure will represent you how many rows are there, how many columns are there, the number of rows and the number of columns along with the all list of variables will be represented by the str. So what is the output of str function? This is the output of the str function. It is indicating that 45 number of cars I have in data set and 39 columns we have. The column number 1, column number 39. These are the 39 columns in my data frame. Similarly, data frame, what is the data frame? Data frame is like a table in Excel. We can extract its variable with the $sign. So how $sign will be used? $sign, the name of the data frame. In my case, it is CARDF. So I have to use CARDF. And in which column I am interested? Suppose I am interested in my DV, the price. So how I have to write down any specific column of my data frame, the data frame name, the $sign, and the column name. So this is the dollar format of representing any of the column into my data frame name and the column name. This is the format which you have to use to specify any of the column in your processing. For example, CARDF $price will represent what? Entire column of the price is referred like it. If you write down only the price, R will produce an error. Why? Because price is not a variable alone. Price is a variable inside a data frame, and the name of the data frame which I have created is CARDF. So every time you have to use this format for identifying any of the column. The CARDF is the name of the data frame and the price is the column name, and in between them there is a $sign. There is no space into this complete word. This is a representation of the output CARDF $price. This is the output of the function. In this output, you can see the cells. This is the price of the first car. This is the price of the second car. And 13 means this is the price of the 12th car. And so on. The price of the 13th car and so on. Similarly, this is the price of the 24th car because this is the price of 25th car. It is indicating as NA. What's the NA is? NA means the price of the car number 25 is not mentioned in my data. Is called a missing data. It is also a missing data. It is also a missing data. So our objective in this workshop today is to clean the missing data. This is our objective. So missing numbers we have, missing number NA. The NAs are the missing numbers we have to eliminate.
So we must have to eliminate the NAs in the data file. This is the called data cleaning. If we want to find out the sum of all prices, so we have to use the function sum. And the format is sum CARDF dollar price. The mean price will be represented, and sorry, that sum of all prices will be represented, and if we are using the function mean, then the mean of the all prices will be represented. But unfortunately, the result will be the NA. Why the result will be the NA? Because if any of the cell contains the NA, then data will not be calculated by the sum function, by the mean function. So we must have to eliminate NAs from the data set. Another way of extracting the data frame is to use CARDF and square bracket, column number, and row number. Row number is to be mentioned first, then a comma and a column number. This is another way of representing a data frame. For example, CARDF 54 means row number 5, column number 4. And the data of row number 5 and column number 4 will be represented. It is 30. In the data frame CARDF, row number 5, column number 4 having a value of 30. You can specify the range in the square brackets if we are interested to show the row number 5 up to 7, row number 5, 6, 7, and column number 3 and 7 only, then this can also be used. And a chunk of data is represented like it. Column number 3 is the price. Column number 7 is the kilometer or the mileage. And row number 5, 6, 7. So this is the output of this command. If you give a command CARDF 5 colon, colon means the series. For example, 1 to 100. If you just want to print 1 to 100 at the console, after the prompt, just write down 100, enter. What it does? 100 numbers will be printed in a serial number. Now, if you want to access the color number 3, to CARDF dollar color in the square bracket 3, the color of the car number 3 will be represented. If you want to see the color number of the car number 3, 4, and 5, so your output will be blue, black, and black. Means car number 3 is of the blue color, car number 4 is of the black color, and car number 5 is also of black color. When to use round bracket and the square bracket? This is the question I am leaving. You have to write down the answer of this in the comment section of this video. Now, after extracting the data in CARDF, we can see the rows of the data, and the first 6 rows of the data can be shown by head, and the last 6 rows of the data can be shown by tail command. So we have the rows, first 6 rows of the data in the CARDF data frame. If we want to see the 10 rows, to just write down head CARDF, 10. If you want to see 100 rows, just write down 100 here. So you have the option of writing the number of rows you want to see in the data frame. Now, this is the segment which we are going to start, which is referred to as data cleaning or data munging. What are the steps in data cleaning? We must have to eliminate the sensitive data from the table. What the sensitive data is? The sensitive data means If you have the CNIC number in your data, remove them. If you have the account number in your data, remove them. All of the sensitive data, you must have to remove the sensitive data, because before sharing the file to someone else, this type of data must be eliminated and ignored. The second very important step is missing columns. Missing column means we must have the all necessary columns for data analysis. For example, if we have the car data frame like Toyota Corolla, and we are missing the column of price, then that was a very, very important column. Without that column, none of the purpose of this analysis will be solved. So we must have the price column into the data frame, because that is my dependent variable. So if we are missing the dependent variable, and as well as if we are missing any of the important variables, for example, the car mileage is a one of the very important variable, how much miles the car ran. So if we are missing that specific column for predicting the price, so it is also alarming for us. So we must have to identify all of the columns which are necessary for the analysis. The variable name should be appropriate. Duplicate rows, there should not be any replicated rows. We must have to eliminate the replicated rows. If we have the missing numbers are actually referred to as NAs. So if we have the NAs, so we must have to remove the NAs from the data set. If we have the outliers, because outliers are the extreme numbers on the either side, lower side or the upper side, we must have to eliminate the outliers before analyzing the data, because outliers will distort the pattern of the data, which distort our model. So we must have to overcome the outliers. Then we have to check the classifications when the data is normally distributed or not. If there are a misspelling or the extra spaces, we have to eliminate them. Numeric data distribution like bell-shaped or symmetric or a positive skewed or a negative skewed or a bell-shaped, what type of distribution is there, what type of classification is there, we must have to identify them. So this, in this presentation, remaining part of the presentation, we are dealing with the duplicate rows, outliers, variable classifications. So these are the three important things which we are going to address in the remaining segment of the presentation. This is yes, no specification is you have the sensitive data, remove them. If you do not have the sensitive data, move forward, and so on in the same way, one by one step you can follow. Removing the missing number is a one of the very important aspect. Removing the missing number. Missing numbers are NA in all of the data processing softwares, and NaN is not a number, which are not number. In mathematics, there are the several situations which are not not a numbers, like infinity upon infinity. These are referred to as indeterminate forms. So if we have NaN, so this is either infinity or not a number. And if we have Na is a missing number, so we have to overcome the NAs. NaN not a number and NAs are. What is the difference between the Na and the Na in double quotes? You have to answer this question into the comment segment of the video. Now we are going to specify the sum of the very important functions which are used for data munging. Head and tail commands are already defined. First 6 rows will be shown by head and the last 6 by tail. Is.na is a function which returns the true or false status of the each and every cell in my data frame. If we use any of the function, means if any of the cell having an NA, that this will be true. If all the cells are full, then the any function will return false, means there is no NA in my data set or my data frame. Call sum will print the number of missing numbers in all of the columns, and na.omit will use to remove the NAs. So this is very important. To remove the NAs, we must have to use this function na.omit. In the bracket, we have to specify the name of the data frame. Complete dot cases is another way of handling the missing numbers. All those cases in which there is no missing number is included in the complete dot cases. So these are the very important functions which we will use for data munging or removing the missing numbers. We are creating a clone of the data frame. CarDF is the original data frame. CarDF2 is a clone of this data frame. Why we are making the clones? Because after removing the NAs, original data will remains intact, and the changes will be made into the new data frame, which is referred to as CarDF2. The very first function is.na CarDF2. What is CarDF2? CarDF2 contains the data frame of Toyota Corolla cars, which were mentioned on slide number 4 or 5. Is.na false. The cell number 1, ID of the first car is false, indicating what? This ID is available. False means the data is available here. And if there is true in any of the cells, which indicates this is basically a missing number. The true means the missing number, and the false means the complete numbers. The result of any is what? True. Why it is true? Because we have several NAs in this data frame. If we apply the sum command is.na, then this will reflect the total number of the missing data in the CarDF data frame. So all of the data in the CarDF data frame, if there is any NA, the total will be calculated by the sum function. If any of the part is there, we have to specify by using the any function. Call sum function will calculate the NAs in every column. Is.na in CarDF, every column is checked. If there is NA in any column, the sum will be calculated. The result will be how many NAs there are in this data frame. So what are the function which we have? CarDF2, and we want to find out the NAs in the first 10 columns. Only in the first 10 column. This will find out the NAs in every column. This will find out the NAs in all columns. Before the comma, we have blank. Why? All rows. The name of the data frame is CarDF2. This is the checking of missing numbers. Call sum will calculate the missing number in every column. This is called function within a function, nested function. Is.na is embedded within the call sum function. So this is the structure of embedded function. Now na.omit and the new data frame is CarDF. So all of the data which are missing in nature from the CarDF2 is now to be stored in CarDF2 again. So before omitting the data, we have a large data set, and after omitting the data, we have a short data set, because all of the missing numbers will be eliminated and stored in the CarDF2. Summary command will represent is there any NA or does not have NA. The next step is imputing the NA. What is the difference between removing the NAs and imputing the NAs? Removing the NAs means removing all the rows which have missing numbers. Imputing means compute. For example, we are going to impute by means. Compute the mean of the all available rows. This is called truncated mean. And this truncated mean will be replaced in the missing numbers. This process is referred to as mean imputation. We can use either the mean imputation or we can use either the median imputation. Both type of imputation can be used. For imputation, we are making another data frame is a CARDF3 and CARDF4. These are the two more data frame. In CARDF3, I will use the mean imputation. In CARDF4, I will use the median imputation. So what is to be do? On the left-hand side, we are going to identify only the missing cell in the price column. On the right-hand side, we are going to identify only the available prices. And the mean of the available prices are computed. Na.rm is equal to true means what? Na.remove. Rm stands for remove. So this is the mean computed for the variable prices after removing the NAs. These NAs were not physically removed. These NAs are logically removed for the computation of mean. After computing the mean, the number mean is stored in all of the cells which are empty, which contains the NA. So this mechanism is referred to as mean imputation. In the same way, if I use the median here, the process is referred to as the median imputation. The mean imputation and the median imputation are the two techniques which generally used to overcome the missing numbers. Similarly, the missing numbers from the mileage column by mean and the imputation, median imputation for the variable kilometer. So we have some of the NAs in the kilometer column. The median is computed for the values available in the kilometer column, and the median is computed. The median is then stored in all of the empty cells in this kilometer column. So this is the way of computing median and storing the median into the empty cells. This process is referred to as median imputation. Now, at this slide, we have the 4 data frame. The CAR data frame is my original data frame. The CARDF2 contains the complete data in which the missing numbers were eliminated, means the size is reduced. In CARDF3, we have the data in which the mean imputation was used. Size of CARDF, CARDF3, CARDF4 are same, while the size of the CARDF2 is reduced because the missing numbers were removed. Data type conversions. As in the early part of this lecture, I told you there are the major types are some of the data is nominal in nature, some of the data is ordinal in nature, means categorical data. Categorical data in R is referred to as factor data. Factor data. Factor data means the categorical data. This data may be nominal in nature this data may be ordinal in nature. Both are called factors. So we must have to convert all of the variables which are categorical into the factor. So the one of the variable is fuel type. The fuel type is a variable in which we have the three types of fuel, and we are converting this variable into the factor and store converted variable into the fuel type again. Means no new variable is computed here. The old variable is used for the replacement purpose too. So this is called converting a variable into factor. On the left hand side, we have fuel type as a factor variable. On the right hand side, we have the fuel type as a string variable. The string variables are in double quotes, and these double quotes will be converted into the factor variable. Similarly, the color variable is also converted into the factor variable. The colors are like these: red color, blue color, and so on. So this is called a string, not factor. But if we converted it into factor, it will convert into the levels. The levels means what? Levels means how many number of colors we have. This is called the level of my data. The same variable is used on the before converting and after converting. Duplicate rows. If you have the duplicated rows, you must have to eliminate them before using into any model. Duplicated rows, there are the several functions: duplicated car df3, sum duplicated car df3. This will calculate how many rows are duplicated. So you can see that there are the 9 rows which are duplicated. And you can find out the structure before removing the duplicated rows. There are 1445 rows and 39 variables. In these 1445 rows, there are the 9 rows which are replicated. So we must have to eliminate these 9 rows. Table command will do what? Table command will print a table of the duplicated rows by column number 1. Because the column number 1 is the ID number, car number. So car number 9 and car number 9 is replicated 2 times. Then there are the 2 rows which contains the ID 9. So we must have to use the column number here for which we want to removing the duplicate rows. So the column number 9, row number 9 has 2 duplicated rows. It means row number 9, one row number 9 is original and 2 more rows of 9 we have. The total, there are the 3 rows which have ID 9, which have the ID 9. Row number 16, it has 1 replica. One row of 16 is original and 1 has the replica. It means there are the 2 rows in which the column number 1 has ID 16 and so on. So 2 plus 1, 3, 4, 5, 6, 7, 8, 9. So these are the 9 rows which we have in my data frame. Now, how to remove these rows? Just use a function unique. Unique function will do what? Only the unique rows will be transformed into the car df3. So from the car df3, we have the replicated rows, and after using this function, only the unique rows will be transformed into the same data frame. You can use the different data frame on the left hand side, but I'm using the same data frame because I don't want to use more data frame into this analysis. the unique function. Instead of removing the replicated rows, we are extracting the unique rows into my data frame. So this is the technique which we used here. After extracting the unique rows, we can see that the data frame now contains 1436 rows. Means the 9 rows has been eliminated from this data frame. Now we can find out the descriptive measures of the data frame after cleaning. We can compute the mean, we can compute the median, we can compute the standard deviation. Before the cleaning, whenever there was NAs in the data frame, we cannot compute these 3 functions because the results of all of these descriptive measures will be NAs if we did not remove them. Now we can calculate these NAs. What was the answer before removing NAs? Answer was NA, 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 and after removing the NAs or after imputing the NAs, because in CAR DF3, we did not remove the NAs. Basically, in CAR DF3, we imputed the NAs by means. So the prices, the mean price, the median price, and the standard deviation of the price. What is the difference between the mean price and the difference price and the median of the price? Why these two averages are too distinct? Mean is too far from the median. Why? You have to answer this question into the comment segment of this video. Making the frequency table. We can make the frequency table of color by the table command. The factor variable should be used. The main purpose of making the factor variable is to make the tables. So color is a factor variable. Before making the color as a factor variable, we cannot use that variable into the table. This proper table will not be shown. After making the color variable as a factor variable, we can use the table command to make the appropriate frequency table. 3 cars are of beige color. The most frequent color is blue because 283 cars are of blue color and 278 cars are of red color. So the most frequent cars are red and the blue colors. Similarly, we can create a frequency table of the fuel type: diesel, CNG, petrol. 1,264 cars are on petrol, 155 cars are of diesel, and only 17 cars are of CNG. The table command, two-way table can also be formed. Two-way table means what? Bivariate frequency table. I am using the two-factor variable, type, and the color both in one table function. What is the output? The output is on the rows we have car types, fuel types. In the column we have the colors, and the rows are bifurcated and segmented. In the same way, we can use another third factor variable here, another fourth factor variable here in this function to make the frequency table in more advanced form. But the bivariate and the univariate table are the most popular table. You can have the output. The next segment is making the subsets of the data. Subset of the data means we want to extract the cars which are blue in nature. Only the blue cars. So we are going to extract the blue cars and another data frame we are going to create. The subset command, color is equal to blue, double equal to is indicating a conditional operator. Color is equal to blue is a condition. If the car having a blue color, the condition is true. If the car doesn't having a blue color, the condition is false. The condition is true. All those rows from the car DF3 which have a color blue will be stored in blue color cars. Means it is a short data frame. In this short data frame, we will have a subset of cars which have only the blue colors. In the same way, if we want to have all of those cars which have a mileage more than 100,000, so we have to make a condition here. What the condition? This is the condition. Kilometer is greater than 100,000. Means we want to store all those cars which are too old cars and their mileage is very high. So the subset is created and the name of the new subset is high mileage. In the two new data frames, blue cars and the high mileage, in both of these two new data frames, the number of columns are same, but it has the less number of rows as original data frame because subsets are created. It has only the blue cars while the car DF3 have all colored cars. It has only the 100,000 more than mileage car, but car DF3 having all cars which ran very less mileage as well as very high mileage. So these two are called the data subset.
Identifying and removing outliers. The first question is, what are the outliers? Outliers are those numbers which are either on the upper side or on the lower side, very extreme. For example, in a class, there are 50 students. If some students got the marks 0 from 100, and 2 or 3 students of the class got the marks 99 or 100, these two sides are referred to as outliers because the most of the class containing the marks around 50 out of 100, and there are the 2 or 3 students who got 0 out of 100, and there are 2 or 3 who got 99 or 100. These two sides of numbers are referred to as outliers. If before going to analyze the data, we must have to remove the outlier. This is one option. And another option is to impute the outliers. What is the meaning of impute the outliers? Meaning of impute the outliers means we calculate the truncated means of the remaining data, excluding these 3 or 4 or 5 outliers, and then fill these outliers by the truncated mean or by truncated median. This process of eliminating the outliers, or instead of using the word eliminating, I'm using replacing the outliers by the truncated mean or median, is referred to as handling outliers. So this is the one of the purpose of identifying and removing or imputing the outliers. So what we have to do first, we have to first identifying those numbers which are outliers. So there are the two methods. One method is called the computing the interquartile range and calculating the two limits by interquartile range, the lower limit and the upper limit. Above the lower, below the lower limit and above the upper limit, what are the numbers that are said to be the outliers? So we have to either remove the numbers which are below the lower limit, lower bound, and we have to remove the numbers which are above the upper limit. These two numbers are removed. And after removing them, we have the data which is referred to as streamlined data or clean data. The second option is to calculate the z-scores. The numbers which are below -3 are referred to as outliers in z-scores, and the numbers above +3 are referred to as outliers in the z-score methods. So we have to overcome these two situations. The lower limit of or the lower bound can be computed by Q1 minus 1.5 times of IQR, and the upper bound is computed by the Q3 plus 1.5 times of IQR. Another method of identifying the outlier is to display the two graphs. One graph is referred to as histogram, and other graph is referred to as the box plot. Box plot and the histograms can be drawn with the help of hist function of prices and the box plot of prices, or the price column. The box plot drawn by the first command is vertical. To make it horizontal, you have to put another parameter in the function, which is referred to as horizontal is equal to true. The actual box plot will be represented in a horizontal manner. So you have to identify the outlier by box plot. This is the histogram, and this histogram is indicating that the numbers, these numbers, which are approximately prices are 20,000 and above. Very few frequency of these numbers we have. So these numbers are referred to as outliers. If we eliminate these outliers, then the distribution will be approximately like it. It's a positive skewed distribution, but the influence of the high prices, which are more than 20,000, should be eliminated from the data to clean it, or the prices more than 20,000 will be replaced by the mean of the truncated data. Truncated data means the means from 5,000 and 20,000. The mean from 5,000 to 20,000 is to be computed, and all of the numbers which are above 20,000 are to be replaced by the truncated mean. This is the one method. So this graph is indicating that we have the outliers on the upper side only. There is no outlier on the below side, right? Lower side. Now, another method is the histogram, which is identified by horizontal. And you have to identify these numbers. This is called upper limit, or the upper whisker, or right whisker. This is called lower whisker, and these numbers which are up more than this figure is referred to as outliers. Now, what these numbers are representing in the box plot, this number is referred to as first quartile. The first quartile, this is not the first quartile. The first quartile will be at the bottom of the x-axis. And the second quartile is the median. The second quartile is this number. This is the second quartile. And the third quartile is this. This is the third quartile. So we are identifying the quartiles by the box plot. And after computing the quartiles, we have to compute the interquartile range. How can we calculate the interquartile range? This is the difference between the third quartile and the first quartile. The distance, this number minus this number. This is called IQR. So the first step is to identify the quartile, and the second step is to calculate the interquartile range. And the distance below the first quartile is called up to this this mark. This is called left whisker, and this is called right whisker. So these are the elements of a box plot. The purpose of our box plot, there are the two purposes of the box plot. One is to identify the outliers if there are any on the either side. If we have some of the dots here below the line, so we call them also outliers. And the second purpose is to identify whether the shape is symmetrical or not. If we have the left whisker and the right whisker approximately same or equal, we can refer to as symmetrical graph, or a graph bell-shaped graph. So this is the way of identifying the outliers and identifying the shape of the data. The first quartile can be computed by the quantile function with the probability of 0.25, because first quartile is defined as the area below the first quartile is 25%. So you have to identify the probability 0.25 and you have to identify the probability 0.75 for computing the two quartiles. Then the interquartile range is computed. After computing the interquartile range, the lower bound and the upper bounds are computed. LBQ1 minus 1.5 times of IQR and UB is Q3 plus 1.5 times of the IQR. Above the UB and below the LB, the numbers are referred to as outliers. Now we have to remove the outliers. Means those numbers which are below the lower bound and those numbers which are above the upper bound are referred to as outliers. So actually in this command, we are not removing the outliers. We are actually extracting the correct figures, because price is less than equal to upper bound are the correct figures, and the price above the lower bound are also the correct figures. So we are identifying the correct figures, means we are eliminating the numbers which are below the lower bound and which are above the upper bound. So these numbers are eliminated, and then the remaining rows are to be stored in the same data frame 3, and all columns. Space here after comma, this space here after comma is representing that all columns are extracted, but the rows only in which the prices are in this range. These prices are stored in a new data frame. That data frame is not a new data frame, is a data frame which we are using before and after the same data frame. It means the data is extracted from CARDF3 and stored in a CARDF. Before the CARDF3, we have a larger number of rows, and after implementing and running the function, we have the smaller size of the data frame, because the rows which are referred to as extreme numbers are not extracted to the new data frame. So this is below your upper bound, and this is above the lower bound. So below the lower bound and above the lower bound, above the lower bound and the below the upper bound are referred to as the correct figure. So I am basically identifying this like a price is greater than equal to lower bound, and the price is less than equal to upper bound. These are not the outliers. These are the correct figures. And we are extracting these correct figure and stored in this data frame. And what are the outliers? Price is smaller than lower bound, and the price and above than the upper bound. These are the outliers. So we are not extracting these rows and these rows, because and in between we have or. Here we have and, but in this case we have or. Why? Because either those side or either those side. But in this case we have and, above the upper bound and below the upper bound, above the lower bound and below the upper bound. These are the correct figures. So instead of this can also be done by using a subset command. Subset command, we are extracting the price less than equal to your upper bound. I am using only the one side here because we have the outliers only on the right side. That is why I used only the one side here. If we have the outliers on the both of the sides, then the both should have to be reflected into this command. So either subset or extracting. These are the two techniques where to remove the outliers or to extract the not outlier rows. Outliers by z-scores. The second method. So either you can use the quartile method or you can use the z-score method. It is simple. Z-score method is quite simple. You have to compute the mean of the prices. You have to compute the standard deviation of prices. And then the z-scores are to be computed. So what is the formula of z-scores? All of you are familiar with the formula of z-scores. Z-scores can be represented by z is equal to x minus mean divided by standard deviation. So I have computed the mean by MEN in a variable MEN, and I have computed the standard deviation. This is the function SD, which is computing the prices, the standard deviation of prices, and this is stored in std. So instead of writing z-score in this way, actually the z-score in my case is the variable is price, and the mean is MEN. In this variable, I have stored the mean, and in denominator I have std in a small letter. So this is the value, this is the way of computing the z-score in my case. So the formula, you can compare the formula. This is the same formula as I described here. The z-score can be described by the price minus the mean and divided by the standard deviation. There is a bracket. There should be a bracket according to the Podmas rule. So now, after computing the z-scores, we have to extract the numbers which are more than -3 and which are less than +3. So instead of more than and less than +3 -3, I'm using absolute value of the z-score should be 3, less than 3. Absolute value means the negative values are assumed to be plus, and 3 is a limit. So -3 and +3 both will be included in this function in this way, and all rows. Blank after comma means what? Blank after comma means all column. And only those rows which have the z-score below or less than 3, below or equal to 3, this is absolute value, means negative and positive both sides. So these numbers are extracted and stored in a new data frame, which is called as the DF6. So in DF6, I have removed the outliers by z-score method, while in CARDF3, we have eliminated the outliers by using the quartile methods. Remove the outlier, is this correct? You have to answer this in the comment box of this video. Removing the outlier, is this correct according to the given function, or we can use the another words for the process I have implemented here? Just comment it. And the last segment of this workshop is splitting the entire data in the test train files. What is the train file? The train file containing the data set which have to be used for training the model, and the test data frame contains the data set which will be used for testing the model. So training the model, this will be used for training purpose, training the model. And this will be used for testing the model. So what these files are nothing, the entire data set of Toyota Corolla, 1, 2, 3, around 1400 rows we have. All columns, randomly 70 to 80% data. 70 to 80% data will be stored in training file, and the remaining 20 to 30% data will be stored in the testing file. Only the 2 segments of the file will be created on the random basis. This will not be my choice that I have to break the file from this point. I will not recommending this procedure, breaking the file by yourself. It is a random process which we will use the sample command to process this. The sample command, the remaining, these cases will be stored randomly in the trained data set, and the remaining data randomly in the test data set. So this is the purpose of splitting the entire file into the 2 segments. The sample command will be used. I'm using 80% and 20% probabilities. Now, these are the 3 commands which you have to use. The first command, you have to identify how many segments you want to split. We want to split into the 2 segments. One segment is called train, another segment is called test. The first one will be the trend, because I 80% use 0.8 will be used first and 0.2 will be used second. So this is the training part and this is the testing part. Probabilities are to be identified. Replace is equal to true means probability by with replacement. If you are using the replace is equal to false, the probability by without replacement will be used. Without replacement, the element will not be repeated. But in replacement, the element can be repeated. A name selected first can also be used again from the CardDF3. So how many rows we have in CardDF3? We have 1400 and something rows in CardDF3. So you have to first identify how many splits you need. If you need to have 3 splits, then you have to identify the 3 probabilities here. Probability number 1, probability number 2, probability number 3. So if your splits are 3, then 3 probabilities are to be identified. If your split is 2, 2 probabilities are to be specified. This is identifying how many rows you have in your actual data frame, and replace it equal to. So at least these 3 parameters are to be identified. The first parameter is the number of splits. The second parameter is how many rows in your actual data frame is. The third one is replacement by with replacement or by without replacement. And the last is the probability of splits. But the first one and the last one should be matched. If you have the 2 numbers here, the 2 probabilities should be there. If you have the 3 numbers here, the 3 probabilities should be there. If you have the 2 numbers or the 2 probabilities, the 2 sets are created. Set number 1 and set number 2. If you have the 3 splits and the 3 probabilities, then we have the 3 data sets. Training data set, and someone is called as testing 1 data set and testing 2 data sets. If we are computing the 3 data sets, because sometimes some people test the model for the 2 different testing data sets. Testing data sets 1, testing data sets 2. 2 times the model accuracy will be checked. But generally the people do it into the 2 segments. Then you can check the structure of trained data set and you can check the structure of test data set. trained data set have all columns as we have in your actual data frame, CardDF3. But the number of rows are 80% rows will be in training data set and remaining 20% rows will be in your testing data set. After checking the structure of train and test, you can see that if we add these two number of rows, the actual number of rows will be completed. So these two data sets which created here, train and test, will be used for model training. So in the predictive analytics, we will use these two the data set for model training. This is the end of this lecture. If you have any comment or if you have any question regarding the lecture and this webinar, you can drop your question into the comment segment of this video. I will answer your question accordingly. Thank you very much for attending this workshop. Allah Hafiz.